In this video, I'm going to talk about the different measures of data. So essentially, the measures of central location and the measures of dispersion. So let me go one by one with respect to the different types of measures. Now, when it comes to the measures of central location, essentially, the three measures that we see are mean, median, and mode. Now, when we look at mean, this is essentially the value which is average of all the data points. When it comes to median, this is the 50th element and the value corresponding to the 50th element in the data set. And when it comes to mode, this is the data having maximum repetition or maximum frequency. Let us dig deeper into the different formulas for the measures of central tendency or central location. Now, when it comes to mean, you look at a raw data or a grouped data. For a raw data, the sum of all the values divided by the total number of values is your mean. But when it is grouped, then it is actually the frequency that gets multiplied with the repeated value. So let's consider that value as x. Then x into the frequency divided by the total frequency, which is equal to n. When it comes to median, median is, as I said, is the middle value, the 50th element in the data set. So suppose you arrange the data set in ascending order or in descending order, then the 50th element comes as the median. Then comes the mode. When you arrange the data set again, you look at the value which is repeated maximum number of times, and that particular value is defined as the mode for the data distribution. Let's move ahead and try to understand the different measures of dispersion. Now, what is this measures of dispersion talking about? It is essentially talking about the spread of the data set. Now, when I'm looking at a data set, whether the data set is around mean, around the central value, or it is away from the mean, this measure is captured by measures of dispersion. Now, what are some of the measures? First is called range, which is the minimum value and the maximum value and their difference. So max minus mean is defined as the range of the value. Then comes the next measure, which is called variance. Variance is a measure of how much the values are deviating from the central location, right? And this is captured as a squared value. So to come to a value which is a linear value, we do a sum of square root, and when we do a square root of variance, we get what we call standard deviation. The standard deviation is a measure of dispersion and widely used across different business applications. Now, let us try to understand some of the formulas. I've already talked about range, which is the maximum value minus minimum value. And when it comes to variance, you have the mean of the data set. If you subtract the mean from all the data values and square it, after squaring it, if you sum up all the values and divide it by the number of repetitions, number of frequencies, then that gives you the value for variance. And the square root of variance is your standard deviation. And when I look at group data vis-a-vis raw data, there is a slight change in the formula that you can see on the screen. Now, let us understand the data set and try to understand the distribution. What is the shape of the distribution? Is it, uniform? In a sense, if I split the distribution into two hubs, whether it is symmetric across both the sides or there is a tilted shape of the distribution. That gets measured by another measure of variation, which is known as skewness. Right? And there are a lot of different formulas. One is used by Excel and the other formula is generally a practical usage formula that we use, which is 3 into mean minus median by standard deviation. Now, if you look at the data set and if it leans towards the left, it is called negatively skewed. If it is leaning towards right side, as in the diagram on your screen, it is positively skewed. This is very, very important for us to understand because depending on the skewness, we get to know a lot of things Some of those we would discuss when we come in the live session. Let us go deeper into the next topic, which is quartiles and a measure called interquartile range. So let us understand what is quartile and why do I need to understand interquartile range. 25th percent element is called the first quartile, 50th percentile element is called the second quartile, and 75th percentile element is called the third quartile. Now the difference between Q3 and Q1 is known as interquartile range. Now it's very important to understand interquartile range because of its implication in identifying outliers. So if you see data sets where there are a lot of outliers, one way of identifying the outliers and separating them is through the interquartile range. In that situation, what we do is we use the interquartile range inside the function that is available on your screen. The last in the list of measures for the dispersion is called coefficient of variation, or CV in short. Now this is a fantastic measure for consistency. Now this is inversely proportional to consistency. So if let's take an example of two players who have scored runs over say 10 innings, their averages might be the same, but the standard deviations might be different, or their averages might be different and the standard deviations might be same. How do I judge who has been a better consistent player? This is done by coefficient of variation, the formula for which is CV equal to standard deviation divided by mean into 100. And this is a very useful formula to capture coefficient of variation. Let us understand the application of IQR in a diagrammatic representation. This is available in any spreadsheets that you will be using, particularly Microsoft Excel. There is a function called box plot, and you can see the usefulness of box plot in identifying the outliers. On the screen, you can see three different box plots where you can identify the outliers and the shape of the data is different. So to summarize, we discussed different measures. One is called the central location, central tendency. The other measure is called dispersion. And using those measures, we'll be able to interpret the data better and we'll be able to apply these data in making better decisions.